Now C.
हिट होगा.
Okay, so now it's a hit or a miss?
हिट होगा तो सी है.
D5 is a miss.
हिट.
Hit and hit. Now there is a block C. Then
हिट होगा.
block C hit. Yes. J.
मिस. T1 वाला भी.
J.
CL1
Miss.
will be replaced.
Huh?
CL1 will be replaced.
CL1 will be replaced. Yes, you will replace CL1. That is, you will replace
AT1.
block A. So DT5, and then
J.
C,
सी नहीं J एक टाइम.
J,
T6.
T9, 8, 9.
Yes.
Because now you need to write arrival time. T9, then C,
हिट.
and then A.
ए मिस होगा तो बी CL2 पे आ जाएगा.
Now A.
रिप्लेस होगा मिस है.
Which block will be replaced?
CL2
CL2. Why CL2?
क्योंकि वो
Oldest block.
ओल्डेस्ट ब्लॉक.
A. When A is there, then
80
it's a hit or a miss.
Miss.
मिस. तो वो हिट है मिस.
How many hits are there? 1, 2, 3, 4, 5. How many hits are there?
5.
Now if you look at here, what is the problem? Now if you look at here, what is the problem?
बस वही कि
No, B is not accessed, that's a different thing. That's a different thing. But if you look, there is a problem. If you look at this access string, there is a problem. Which block should not be replaced?
A should not be
A.
replaced.
should not be replaced. क्या
It shouldn't have been replaced.
D should not be replaced and C should not be.
Okay? Because
A is ज़्यादा
Because A, now if you look at here, A was replaced here. A was replaced here, and A was referenced here.
Yes.
If you have kept A in the cache, it would have been more
More hits.
beneficial. And it does not, FIFO does not exploit the concept of special locality. It does not exploit the concept of special locality because it only considered the block which was placed, the placement time. It does not consider the fact that that block, whether it is a highly accessed block or rarely accessed block. Now this is, what is a highly accessed block? In this example, what is a highly accessed block? A. So it has replaced a highly accessed block. So a FIFO policy may replace a highly accessed block. If it's in the oldest block, then it's a problem. Even if it's referenced highly, it does not then exploit the concept of temporal locality or special locality. The same block. Temporal locality, also the special locality. Because if you are accessing the same block, but we can access the different word of the same block. It's not possible. Not maybe at this time, maybe at A, maybe at T1, maybe at T1.
A का word 1 access हो रहा हो.
Maybe we are accessing word 5 on block A. Maybe at T11 we are accessing
Word 7.
word 9 of
Okay.
A. You got my point?
Special और temporal
See, in this
दोनों.
case, which locality is exploited?
स्पेशल और टेम्परल दोनों
Special
हैं।
locality. Not temporal, special.
क्योंकि
Additional.
W5 के टेम्परल में नहीं?
No, temporal also होगा जब W5 of A and W5 of A. That is temporal locality. If you identify the same block, special locality, if an atom is accessed now, it's more likely that the same atom will be accessed in the near future.
लेकिन एक एक केस में तो हम कह सकते हैं ना सर कि एक दफ़ा एक्सेस हुआ है और फिर
Yes,
एक्सेस हुआ है।
but now if you look within the block,
ठीक है सर।
there is a special locality.
विद इन अ ब्लॉक स्पेशल लोकेलिटी है
Yes.
लेकिन ब्लॉक के लिए टेम्परल
You
लोकेलिटी।
will go temporal locality.
ठीक है सर।
Simple. How is the definition? How do you define it? Okay. Now, so how many hits are there?
5 hits are there।
5 hits are there. Now, if we change the replacement policy, so we have another policy that is called as least recently used policy. What is the least LRU? LRU stands for
Least
least
recently
recently used policy. So now we can have again cache line 0, cache line 1, cache line 2 and cache line 3. And we use the same access stream. Which blocks? This is arrival time T0, T1, T2, T3, T4, T5, T6, T7, T8. How many blocks are there?
T9 to 11 तक, T11 तक।
What is the name of first block?
H
H, then
A B C
A, B, C, then
A D
A, D, A,
B C J
B, C, J,
C A।
C, A. Okay, now can we write it like this? These are miss. In the previous case, miss, and miss. It is the same in the previous
Yes,
case.
sir.
So okay, can we write it like this? C. No, not H.
60 nuts is called।
The fourth case, H A B T. H A B C. H A
B C
B C. Now we have H A B C. Here H, then H A, and then H A.
टाइम भी लिखे सर।
Now,
A
now if you look at here, now we are right at time T4. We are right at time
T4
T4. When we are right at time T4, what will happen?
फुल हो गया। When
No,
it bits one।
A is a hit.
hit.
It's a hit. We don't need to replace. It's a hit.
Yes sir।
When it's a hit, so actually, can we write it like this? H, the same. H
H
is same. A is a hit.
B
B and C will remain as it is.
Yes sir।
But if you look at here, H A. So now A is accessed at which point? T4.
T4
A is accessed at T4 and there is a hit at T4. So now what time we will incorporate? Now we say that now T4 A. Initially, if you look at here, so it was T0, T0 T1, T0 T1 T2, T0 T1 T2 and T3. This is T0, this is T4, T2 and T3. Now A is now accessed at T4, so we update it. We say now the block is recently used, and now we should not evict it. It should given be the least priority. When
Yes sir।
so we should replace a block. So we should give it highest priority, not not least priority for replacing. Highest priority, we should retain it. We should retain A because it is more likely
To be born in future.
that A will be accessed
In near future.
in the near future. Now, you access D. When you access D, which block will be replaced?
CL0.
नहीं H
Yes, CL0. Actually, in this case, we should look at the times. Because now T0, T2 is the oldest block, it is not reference. But if H would have been reference, its time would have been updated.
Yes sir.
Then you should not have replaced it.
Yes.
Like let's say H has been replaced at T3. Then the value of H should be T3 or some more value. So we should not replace. So we should maybe replace D. But H is also not referenced.
Yes sir.
Okay, so what is the oldest block? H. Which who will replace H? D.
D
D is replaced at
T5.
T5. D at T5 and there is a miss. A T4 A T4 B T2 and C T3. Next time there is a A.
Head.
Hit. What will happen? A time step will be updated T6. D
T5.
again D
Head.
hit. What about C?
C head.
Then BT7, AT6, BT2, J. J will replace what?
C.
B. B. J. So J,
T9.
T9, CT8, AT6, DT7. Okay, what about C?
Head.
Hit. Then
AB head.
J, T9, AT6, DT7. Then A is a hit.
Yes sir.
A is a hit. Okay, so then AT11, you're right. D, T what?
7.
Okay, hit or miss?
Head.
Hit.
Head. Head.
Miss.
Miss. Yes sir. Head. Head. C का
Head.
है और ये भी head.
How many? 1, 2, 3, 4, 5, 6. There are 6 hits. And in the preview policy,
5.
okay, why is this so? Why is this so?
ये तो डेटा पैटर्न पे भी डिपेंड करता है और इधर लीस्ट रिसेंटली यूज को हम रिप्लेस करते हैं.
Actually, let's do it another example. Okay? Okay, now let's assume we have another C here. Let's assume we have another J, there is M here. What will be replaced?
C T
There is M. It will replace C. M will come here, A will come here, J will come here, D will come here. And next time we have C. So there is a miss now, and there will be a miss again. Why? Because C will then replace what? It will be C, D, C, yes, C, J, AN, and again there will be a miss. But here, if it is T12, at T12, this is a cache line what? M. M. Which will be replaced?
D. Because timestamp is
D. M will be here.
In T12,
M.
T12,
T12. AT11. JT9 and C
10.
10. Now if we again have C, then
Then hit.
hit,
C will be a hit.
T12,
C13.
T12 आ जाएगा.
C13.
T13, yes sir. T13,
C13. Okay. So J
JT9,
JAN
as it is आ जाएगा.
M. Now in this case, it will be a hit or a miss.
Yes,
Miss.
Miss and
hit,
how many hits are there? 1, 2, 3, 4, 5, 6, 7. Here, how many hits are there?
5.
5,
So now this is the problem of the first in first out case. So the least recently used policy is much better.
as compared to P.
Is much better. Compared to what?
P4,
Compared to the FIFO policy. This is a FIFO policy. So the FIFO policy kicks out the oldest block.
Oldest.
Even if the oldest block is highly referenced,
Highly referenced.
even it will kick it out.
Yes.
But then it negates the concept of the principle of
locality,
locality. And actually, maintaining a FIFO is simple in hardware.
Yes.
And maintaining this LRU, implementing this LRU in hardware is
Difficult.
a little bit complex. That's the reason. That LRU is much better than the FIFO policy. Why LRU is better?
locality.
It likes to retain the blocks that are recently referenced. When they are recently referenced, it will likely to retain this block, and it is highly probable that the recently accessed block will be accessed in the
Near
near
future.
future. So it exploits the concept of which locality?
Near future.
Temporal locality. Okay. Now this is FIFO policy. There is a LRU policy. There is another policy that is called as LFU.
Least,
Least frequently used. LFU. So maybe I rub it out.
yes, yes,
So we then study another policy. So in LFU, it stands for least frequently used. Replace a block that is used least frequently. Least frequently. So actually a counter is maintained with each block. A counter is maintained at each block. So there are two informations. T0, 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 T1, T1, T1. But in addition we have a counter, 0. 0 means that H is now accessed 0 times.
only one time. Yes.
0, 0, 0, 0, 0.
Count one से start
0,
करें तो
0, 0 and 0. Now you have A. Now you have
तो एक अकाउंट
A.
हो
So
जाएगा,
actually what will be the count of A?
1 हो जाएगा.
Number 1.
A 1 at time T1 and count is now 1. H 0 0, B 2 0, C 3 0. What is 1 2 3? 1 2 3 is actually the arrival time.
Yes, sir.
H0 is the
Arrival time.
arrival time or insertion time. So it means that H is now inserted at time t0. Okay, now D, which will be replaced.
जो सबसे काउंट भी
H.
कम हो और इससे
D 5 0, A 1 1, B 2 0, C 3 0. What about A?
ए का काउंटर बढ़ जाएगा.
E 5 0, A 1 2, C 3 0. What about D?
काउंटर बढ़ जाएगा.
D 5 1, C.
सी का काउंटर बढ़ जाएगा.
What about J? Now we replace J.
जे तो
Replace a block
B2
that has the least count.
B2 0.
B2. So J.
So when the counter is same, then we use FIFO for replacement.
When the count is not same,
पर टाइम
so
को
then
देखेंगे.
we kick out the oldest block.
FIFO.
FIFO policy. Okay. What about C?
सी काउंटर बढ़ जाएगा.
What about A?
काउंटर बढ़ जाएगा.
What about M?
एम तो
Like if you look at here, count of 1, count of 3, count of
Count of J.
which will be replaced?
जे
J. M what? What about C?
काउंटर बढ़ जाएगा.
Okay. Hit or miss? Hit. Hit or miss? Miss. Hit or miss? Hit. What about D is hit? Hit. J? Miss. C?
हिट
What about A? What about M?
मिस
What about C?
हिट
1, 2, 3, 4, 5, 6. It also has 7 hits. So least frequently used. But it has some associated overheads.
काउंटर भी होना चाहिए.
Because for the cache line field, we not only the valid field,
But the count
the tag field, but also the and actually if you use a 3-bit counter, if you use a 3-bit counter, so actually if it reaches 7, so it then cannot exit. So it is a saturating concept. So it also depends upon the size of the counter. If the size of the counter is 3-bit, so it can maximum count of 7. If it is accessed 9 times, it will not keep track of. If you increase the size of the counter, it will be more accurate. But then the
associative cast
overhead, what overhead? Storage overhead will increase. But if you look at here, what is the storage overhead of 8-way associative is higher, or the storage overhead of 4-way associative is higher for the same cache size?
8
For 8. Why it is higher?
take field
Because the take fields are more. So if you increase the associativity,
तो conflict messages कम होंगे लेकिन
conflict messages will be reduced,
लेकिन
but storage overhead will be. If we have a FIFO policy, the storage overhead is less. But if we use the least frequently used policy,
storage overhead will be
the storage overhead is much higher. So all these things depends on the storage overhead. So actually what is a FIFO policy? In a FIFO policy, the oldest block is replaced. The oldest block is
replaced.
independent of its frequency, independent of its recency. And in the least recently used policy, the block that is least recently used is not used in the recent future, is replaced. Like if A was used in the recent future, A was not replaced. Here in this example. Now if you look at here, which block was replaced? Used in the recent future. A was. So if you want to insert M, you should not replace A, C, J, and D, because these are not 3. Because you should not replace A, C, and J, because A, C, and J was used recently. नहीं समझे? A, C, and J was not used recently. C was used recently. So the only candidate was then left was
D.
now in least frequently used policy. You replace the block that is least frequently used. That is not used too many times. If a block is reference more, then it will not likely be replaced. If the block that is not referenced more, it will be
That will be replaced.
more likely. Okay? Any question? Okay. Now in a FIFO policy, the older blocks will be kicked out. In the least recently used policy, the block that is referenced in the near future, that was referenced in the previous future, will not be replaced, but the block that was referenced much higher in the future, in the past, sorry. The block that was referenced, the blocks that are referenced in the recent past will not be replaced. And the blocks that were referenced in the past part will be replaced. So this is the recent past, and this is the
Far past.
far past. And now in this case, it does not consider the history information. It considers the frequency information. And the frequency information is stored where?
Counter.
So look at the counter. If the blocks that has the least count will be replaced. Now, what about the case when there are 2 or more blocks that has the same count? What will happen?
Time को देखो.
Then you will consider the insertion time when the block will be filled. So the oldest block will be then kicked out. Okay. Now there is another policy. That is called as the random policy. What about random policy?
बस किसी को भी निकाल दो.
It may replace any block. It may be least frequently used. It may be. So the random block is a very, very simplest policy. It just choose a block at random. Maybe it choose a block at cache line. But random policy is not predictable. Even for the same access stream, if you apply a random policy, the number of hits will be different from another time instance if we have the same access stream.
Random भी होगा.
Because it is random. So random policy is simple to implement, but it is unpredictable. Okay? So it is very simple to implement.